video is going to be on the last part of chapter 14, looking at colligative properties of solutions. So colligative properties are properties that depend only on the number of solute particles, not the nature of the particles. So the more you have of something, the larger effect it's going to have. And the three main ways that colligative properties affect chemistry are vapor pressure lowering, boiling point elevation, and freezing point depression. Don't worry about the vapor pressure one for this course. We're going to mostly focus on number 2 and 3. In order to figure out these concepts, we need to understand molality. And so this is going to be, again, depending on the number of particles and a new concentration unit is created. That is molality, which is moles of solute over kilograms of solvent. So remember to keep these separate from molarity, which is liters. So what is the molality of a solution prepared by dissolving 0.10 moles of starch in 0.5 kilograms of water? Is going to be an easy setup ratio. Just take our moles and divide them by our kilograms. So giving us 0.2 molal, or molality. Okay, and notice here we have our little italicized M as our unit. So what is the molality of a solution prepared by dissolving 2.70 grams of methanol in 25 grams of water? We're going to convert our grams to moles using our molar mass, giving us 0.0843 moles. Convert our grams to kilograms, so we divide by 1,000, giving us 0.0250. So our molal here is going to be 3.37. So how these affect boiling point and freezing point is a simple formula for both. The change in temperature equals our molality times K, which is going to be a constant. And so we're going to use different constants whether we're looking at freezing point or boiling point. Here are some examples of how they are different in different compounds, but again, these will always be given. So let's see an example. What is the boiling point of a solution prepared by dissolving 0.10 moles in 0.5 kilograms? Our boiling point of water is 100, and our Kb is 0.512. So we would calculate our molality, dividing our moles by our kilograms, and then multiplying by our constant. So our change in temperature is 0.10 degrees. And remember, we need to know that this is going to elevate our boiling point, so we need to add this to our original boiling point. So remember, this is key. You're going to add that temperature change to whatever the boiling point, usually water at 100.0. So in this case, our final answer would be 100.1. Work on this example on your own. Pause the video now. Okay, so we already have our molality calculated for us. It's going to be very straightforward, taking 4 molal times our constant, 0.512, giving us a temperature change of 2.05. We'll need to add that to our normal boiling point of 100 degrees, giving us 102.05 degrees Celsius. Now, freezing point depression is the opposite, and so you know this concept because this is why we put salt on ice in the winter. So we're going to do the exact same formula. We just need to do one step that's going to be different. So again, our molality for this one, 0.10 moles of sugar in 0.5 kilograms of water. We're going to have 0.2 molal. We're going to multiply that by our new freezing constant. Notice here we're talking about Kf, so our K for freezing. In this case, we'll multiply by 1.86, giving us a temperature change of 0.37. We're then going to need to subtract this, again, freezing point depression, so we're subtracting our temperature change from 0 degrees. So now our freezing point of our new solution will be minus 0.37 degrees Celsius. Pause the video now to work on this example. In this case, we're given grams, so we're going to need to convert those to moles. And again, we're given grams of water, so we're going to need to convert that to kilograms. So this answer is minus 15. Let's see how we get there. We'll take our 100 grams of our compound, divide by our molar mass, giving us 1.61 moles. We'll then divide by 0.20 kilograms, so to make sure that our 200 grams is represented in kilograms. We'll then divide those two numbers, giving us a molality of 8.05. We'll then need to multiply that by our constant given from the question, our Kf, giving us a temperature change of 15 degrees. Since this is a freezing point, we need to subtract that from our our normal freezing point of water, giving us minus 15 degrees Celsius. That's it for chapter 14.